All right. Today what we're going to do is a demonstration regarding concentration. When we talk about the concentration of salt in water, we're dealing with the amount of salt that's in the water. And we're going to use a unit called parts per million. And that's abbreviated PPM. Okay? To really understand what this looks like and how small a concentration of parts per million is, I'm going to do this demonstration. Right now we have 100 milliliters of water in cup 1 right here. I have mixed together some like Crystal Light drink mix. It's supposed to be red and blue, make kind of a purplish color, but it's dark. All right. This is known as one part per one. The rest of the cups have 90 milliliters of water. And what I'm going to do is measure 10 milliliters of this cup and pour it into here. When I do that, that's called a serial dilution, and that will be 1 part per 10. Then I'll take 10 milliliters from this cup and pour it into here, and that'll be 1 part per 100, and then so on and so forth down the line. Okay, so here we go. I have a graduated cylinder. I measure 10 milliliters and pour it in here, and I have a stirring rod right here that I'm going to use to stir. The hard part about this is getting this exactly right without spilling. And I have 10 milliliters. Oops, put that right there. And pour that in here and mix it up a little bit. Now this drink mix has some dissolved solids in it, right? But you can see it has the concentration has gone down quite a bit from 1 part per 1 to 1 part per 10. Okay. Now we're going to take this and measure 10 milliliters. Oops, a little too much. And then once we do all of the serial dilutions, we will check for something called the Tyndall effect. Now, the Tyndall effect occurs when there's very, very small particles in a fluid, and that could be water or the air. And if you shine a light through the fluid, you can sometimes see the actual particles. And that occurs due to the light bending all around the particles, and the particles reflecting and refracting the light back to your eyes. You can see this most often in fog. If you drive down a road on a foggy day, the water particles in the air can be seen, can literally be seen in the headlight beam, and that is the Tyndall effect. Okay, so just think to yourself as I'm doing this, what we see with the color of the water as we go from 1 part per 1. Now we're at 1 part per 10,000. Now I'm mixing 1 part per 100,000. And eventually we'll get to 1 part per million, which will be our last one right here. And that if you go to the Canoes River or Crabtree Creek and look at the water, it may look like it's clear, but it's going to have a lot of nasty stuff in it, a concentration of chemicals and pollution that you may or may not be able to see. And there's different tests that you can do for to find out that stuff. Now what we're going to do, I'm going to use my cell phone and shine the light, the flashlight, through each cup. So here you can see the light beam is being scattered through the drink, the water. You can see it kind of here and here. Okay, so there is a Tyndall effect in 1 part per 1. All right, let's do 1 part per 10. let's find it right here. I can see a little bit of it right there. All right. And so that's 1 part per 10. So I'd say yes for the Tyndall effect. Here, I would definitely say yes for the Tyndall effect. And here, it might be hard to see, but the color is, actually it is a little bit, you can see it. The color is a little bit pinkish compared to the bottom row right here. But for the Tyndall effect, can we see it? I would say a little bit, yeah, I can see some particles in there. And this one, this is 1 part per 10,000. I would say no. From my eye, I can't see really any of the red or purplish particles from the drink mix. And the same thing here. And then definitely with 1 part per million right here. Okay. So this is called a serial dilution. Serial spelled S-E-R-I-A-L. And what we have done was mix different concentrations of you can think of this as salt or think of it as pollution. Okay. And it's important to know this because over the next few days, we're going to be talking about the concentration of pollutants and salt in the oceans, and they're going to use the unit of parts per million. If we were to continue this, we could do another dilution, and that would be 1 part per billion. And there is occasionally pollution content using that unit. So this is what 1 part per million would look like in water. There are questions to answer, about 4 or 5 questions in Moodle. Please answer those after you have watched this video, and let me know if you have any questions. Thank you.